Hello, I'm trying to record myself today using the Screencastify in the classroom. Hopefully it is going to be a little better sound quality today. I'm going to just say again, please pardon my hand in the video. Today's notes, we're going to be talking about converting between fractions, decimals, and percents. So the first thing that we need to look at here, that it says, recall that a rational number can be written as either a fraction, terminating or repeating decimal, and percent. The new part here is really that terminating and repeating decimal statement. We have now talked about the difference between those two. The only one that's not in there is non-repeating decimals, and non-repeating decimals are decimals that really never ever end either. So that's why they're not being classified right here. So we want as a fraction, decimal, or percent. And that can be a rational number. So for question number 1, again, as I said before, percents can be solved many different ways. So the way that I'm showing you doesn't necessarily have to be the one and only way to solve this problem. Example 1 is talking about to be elected, a U.S. presidential candidate must receive more than 50% of the 538 electoral votes. In the 1976 presidential election, Gerald R. Ford received 240 electoral votes. So did he win the election? Explain. So I am imagining that most of you are looking at this and saying, well, 50% means half. So if I was to take 538 and just divide it by 2, would that give me half? And that's going to give me 269. And so if half of 538 is 269 and he only got 240 electoral votes, then obviously he didn't have enough to win the election. So that's one way to do this. Or you could say, as a percent question, 50% over 100, because remember I said any number that is in front of the percent sign, anything that's in front of the percent sign, you can always write it over 100. 50% of the electoral votes. So that's telling you that the 538 would go in the whole section or the part section. And then I would be looking for how many votes did he actually receive, or actually, I'm sorry, what 50% of 538 is. I go through and I cross multiply, and I would also get the answer of 269. Or you could figure out yet another way that Ford did actually receive 240 votes, and he received 240 votes out of the 538. So when I just said out of, that means I'm setting up a division problem. And when I divide that out, that's going to give me 446 thousandths, which to change that from a decimal to a percent, I'm going to multiply by 100. Get that out of the way. Multiply by 100, which will give me 44.6%, which means no, he did not have enough votes. Or enough electoral college votes. Okay, so there is a prime example of where I just showed you 3 different ways, and I'm sure that you guys could come up with some others. So I'm just going to really ask you to go ahead and give questions 2, 3, and 3 a shot. And when you guys come back, those will be all complete for you. So I have here that on question number 2, this is one way that I figured it out. I think that if you got 71 questions correct out of 85, I'm going to take 71/85 and divide it to give me a decimal. And then I took that decimal and I multiplied it by 100. And obviously to round that number to the nearest whole percent would become 84%. You also could set up a proportion where you had that we're looking for the percent. So n divided by 100. N would represent the percent that we got correct. And again, since it's a proportion, you have to write what's equivalent of the percent correct directly across from that, which would be the amount that he got correct. And we know that he got 71 correct, so I would put 71 there, out of the whole test, 85. Notice the whole test is across from the 100%. You go through, do the cross multiplication, and you will get the same exact answer. Number 3 is saying that, oops, I didn't want you to see this one just yet, that A research article claims that 64% of the people in the United States can roll their tongue. So I put 64 divided by 100. That's the percent that can roll their tongue. That can roll their tongue. So this would be the amount that roll their tongue. And I get my answer of 160. They say they want us to now write the ratio of students who can roll their tongue to the number of students. And it's 160 to 250 students. You do not need to reduce this. I know that we have had the habit of always writing our ratios in lowest terms, but in this scenario, since they are specifically asking for the number of students and people, you can just go ahead and leave it as 160 to 250. So what I want you to notice again is that I'm marking up my paper to put my little ratio here. Okay, so why don't you guys go ahead and give number 4 a go as well. And here is my answer of 75 divided by 100 equals x over 24, because there's a total of 24 hours in a day. So I got that he gets 18 hours of sleep a day. I wish that's a lot. So 18 to 24 would be the correct ratio there. Okay. So this next section is a key concept dealing with how to go from fractions to decimals, decimals to fractions, fractions to percents, percents to decimals, and so forth. So I tried to organize this information as best I could for you. So we have fraction to decimal, decimal to fraction, fraction to percent, decimal to percent, percent to decimal, and percent to fraction. And really, if you're given a fraction, you should be able to change it to a decimal to a percent, from a percent to a decimal. If you're given a percent, vice versa. These are really kind of straightforward. Some of you already know these. Some of you just need a kind of refresher. So fraction, remember that all fractions are division problems. So divide the numerator by the denominator. The only thing that they're missing here is they did not show you all the lovely meat to this question. They didn't show you all their work. To go from a decimal to a fraction, I would read this number right here as 125 thousandths. Thousandths with a th at the end. So as soon as you say 125 thousandths, you put it over 1,000. They're saying write it as a fraction over a power of 10 because 10 to the third is 1,000. So that's where they're getting that from. Then, of course, simplify. To go from a fraction to a percent, you can convert it to a decimal. And then to convert to a percent, you would now multiply by 100. You're moving that decimal 2 places to the right. Decimal to a percent, again, they're giving us this shortcut here of moving the decimal 2 places to the right. What allows us to do that is to multiply by 100. And then you have to add the percent symbol on. To go from a percent to a decimal, we want to remove the percent sign. So there are 2 ways that you can do this. One, you could just say that you're going to put this as 12 5/10 divided by 100, and then go ahead and you can pick your calculator up and divide those out, and you should get 125 thousandths. Or you're going to move the decimal point 2 places to the left because that is the same thing as dividing by 100. And I will be checking your notes to make sure that you have all these little snippets written on there. Percent to fraction is asking you to convert to a decimal first and then to a fraction. So you take the 12 5/10, convert it to a decimal by dividing by 100. And after you divide it by 100, you now read this decimal as 125 thousandths. So you place it over 125 thousandths and simplify. Or same thing again, you could put the 12 5/10 divided by 100. And then since you know that you need to move this decimal over 1 place, you would move this decimal over, and there you get the 125 thousandths as well. So 2 ways to do that. So for question number 5, they're asking for us to write this from a fraction, decimal to a percent. And again, you are going to be allowed to use your calculator. So a fraction, all fractions are division problems. So 3 divided by 4 would give me 75 hundredths. And then to change that to a percent, remember you are multiplying by 100 So that would give you 75%. I'm now going to ask for you guys to go ahead and try to fill in the rest of the chart on your own. Okay. So I am getting here an answer of, I said 12 hundredths. So I wrote 12 divided by 100, which then equals 3/25 when I reduce it. 12 hundredths, if I multiply that by 100, will now give me 12%. 175% is a percent that is greater than 100%. So my decimal should also be greater than 1. So what I'm doing to remove the percent sign is I'm dividing by 100. And when I divide by 100, I move that decimal point 2 places to the left. So that will give me 1 75 hundredths. Then I read this number again as 1 75 hundredths. So I now place 1 over 70. Excuse me, I don't place the 1 over anything. The 1's over to the side, and then I put the 75 hundredths and I reduce that. Make sure you don't forget that whole number at the very end. The last one, I'm taking 6 thousandths and I'm multiplying that by 100, and I will get 6/10%. I'm getting 6/10 of a percent, less than 1%. So I'm getting a very small amount. So I could also go the other way with the fraction. If I read this number as 6 thousandths, that's what I'm doing right here, and I simplify that down to give me 3/500ths. Question number 6 is asking which statements are true. So we just really have to go through and calculate these out. And it says that 1/4, 25 hundredths, and 2 5/10 are equivalent. Well, 2 5/10%.
Will Weatherwax entering the building please come to the main office? Will Weatherwax to the main office.
Sorry about that. So 2 5/10%, if I was to take that number and divide it by 100, because again, anything that's in front of the percent sign, you can always put it over 100. And if I was to divide this number out, I'm moving that decimal again 2 places, I would get 25 thousandths. If that's not equivalent to 25 hundredths. Again, that's not the only way that I could prove that one was wrong. You could also take 25 hundredths and multiply it by 100 and see that you get 25%. So I know that that one is not true because this is incorrect. So if you could go through and continue that for the remaining 3 questions to decide whether those are true or not. And so I said that only statement number 2 is true because, and I'm proving my work right here, that I did 2/5 when I actually divide it out. It gives me 4/10, and that's not equivalent to 20 hundredths or 20, so they have written there. And then this is be very careful with number 4. It looks like it's all going to work out, but they don't have the 0 after, or excuse me, a 5 after the 2 here. There's technically a 0. So these are not equivalent to each other. So be very careful there. And then the last question says that what is 24% of 50? Choose a rational number representation to find the exact answer, and then explain why you chose the representation that you used, and then also use estimation to check your answer. So this is a good summary of what we've been talking about all together. So go ahead and give that one a shot as well. So I went through and actually used a proportion to calculate what 24% of 50 is. I am seeing a lot of you, though, are recognizing that of means to multiply. So I do like that some of you are saying that 24 hundredths is the same thing as 24%. And so I'm seeing you go 24 hundredths times 50 to get your answer of 12 as well. That's great. And when they said choose rational numbers are fractions, decimals, and percents. Explain why I chose the representation I used. Well, these are the ones I'm familiar with. And then use estimation to check your answer. Well, I know that 25% is, close to a quarter, and a quarter of 50 would be 50 divided by 2 again. So 50 divided by 2 would be 25, and then 25 divided by 2 would give me 12.5. So I have a, if I divide a number by 2 twice, it's the same thing as dividing by 4. So I get my answer of 12.5, which is close to 12. All right, thank you for watching. I will talk to you guys soon. And again, if you have any questions, please ask me. Have a great night.